right. So today we are going to start chapter 5. And in chapter 5, we are going to discuss probability. There we go. Just needs a minute to focus. Okay. So probability is the likelihood of an event occurring. So when we take a look at a probability of event E, let's say, then when we have that, we're always wondering what happens or what the probability is if that event is to occur, not the other way, where if it doesn't occur. If it doesn't occur, then we would have a different notation or a different way to say that, okay? I just wanted to also let you know, in chapter 5 is not actually required for me to cover. In Stat 1, most of us do cover it because we use probability going forward with our chapters like 7, 8, 9, and 10. So it's really nice to have a good background of some probability, and it's not anything in depth, it's just some light probability, but it's a good background. So when we get into those other chapters, hopefully there's less questions about the probability part of that. That's why I go over probability, and I take this whole week to do that. So I just wanted to kind of mention that. So probability is between the values of 0 and 1. So 0 meaning it's the extreme, no chance. So if I have a 0 probability, it means that there's a 0% chance. That means it is not happening, right? And I say that's extreme because you have to be very certain that something's not going to happen in order for it to have a 0% chance. And on the other side, the flip side here, a probability of 1 is that you're certain that whatever that event is will happen. So it's certain to happen, and 1 just means 100%. So you're going to notice throughout today and next class that I will talk about probabilities. We might leave in fraction form. You can rewrite it in decimal form, or we can write it in percent. So it doesn't matter to me which form you use. I'm pretty flexible with it because it all means the same thing to me. So when we move forward in other chapters, you'll notice when I talk about probability, I'm going to leave it as a decimal though. So I just wanted to kind of let you know about that. We have some notation that we need to discuss before we move forward with any examples. So for some notation, if we have the probability of event E, so this just means the probability of E occurring. So what I want you to know is the notation here, capital P is just representing probability. The parentheses is of, and then E occurring is just E. And that's my notation. We're going to use that notation throughout our time here in chapter 5 when we're talking about probability. And I want you to know I'm not picky about it. So I'm not particular about what you put inside the parentheses, as long as it relates back to what we're interested in. It doesn't have to be anything specific, okay? So I just like you to know that because I don't want you to get hung up on that, okay? So that's my notation for that part. And we have probability of E not occurring. And this is called the complement right here. This little c is called the complement. And this is that probability of E not occurring. So that is just called my complement. So as a little note, probability of E plus probability of E not occurring, the complement, will add up to 1, which makes sense. So I always go back to this little example of rain, because when we look at like I look at my weather app, I'll see 0% chance rain or maybe 100% chance rain, right? We all see these. I mean, these are rare to see these, but we see them. I just saw actually last week, one of the days had 100% chance rain. So when I add up the probability that it's going to rain plus the probability that it's not going to rain, those are my only two options. So they should add up to 1. So complements add up to 1, okay? I can use this formula and rearrange it to solve for one or the other. So I could say, well, the probability of event E occurring is equal to 1 minus the complement of E occurring. Or I can go the other way around. I can say, well, if I want to know the complement of E occurring, I can say it's 1 minus the probability of E occurring. So I can use either one of these or any of those, right? But I can use either one of these if I'm solving for one of the probabilities, and it might be easier, or we might know the complement, or we might know the probability of an event occurring. So let me just, whoops, kind of let that be known like that. That's what that means. The C is a complement, and it means it's not occurring. Okay, so let's take a look at how we get some of these, maybe. My paper doesn't want to separate today. I have the probability of event E. This is just the number of ways E can occur. And it's divided by the number of possible outcomes. So this is how you calculate a probability. This is just the number in E divided by the number in S. And S just stands for my sample space. That's what that's called. So sample space are the total number of possible outcomes. So let's take a look at a quick little example, and we're going to write the notation just to practice that and calculate the complement. And then we're going to move on. So if I say the probability, I should look it up, but I didn't. The probability of rain today, it's probably really low because it's completely blue skies here at my house. But let's just say it's 0.3 or 30%, right? 30% chance rain today. I want to write this in notation. It's good practice before we start some other problems. So anytime you just write this capital P with the parentheses, it's just telling someone you're calculating the probability. It's the probability of, and I'm just going to put rain. And I think that's pretty clear. I think it's pretty clear that I'm calculating the probability of rain, okay? And it's just equal to 0.3. Or I can write this as 30% if I want, right? What if I want to know the complement? So I want to know the probability that it's not going to rain. So since I know the probability of rain, I'm not going to do any research. I'm just actually going to calculate the complement. So I'm going to say rain complement. So this means it's not going to rain. So this is going to be 1 minus the probability of rain, which is 1 minus 0.3, which is 0.7 or 70% right here. Okay. So that gives us a little practice with some notation. So let's take a look, at an example. class consists of 36 students. "12 coffee drinkers and 24 non-coffee drinkers." I want to know, what is the probability of selecting a coffee drinker? Okay, so I have all the information I need right here. So what I'm going to do, I'm going to write my notation out here. So I'm looking at the probability of a coffee drinker, right? So you can abbreviate, you can write it out, you can write P of C, that would even make sense. Whatever suits you, okay? I'll leave that up to you. Now, remember what I said up here in the previous page, that it's the number of ways E can occur, right? Divided by the number of possible outcomes. So E is my event coffee drinkers, and I have 12. So that's the number of coffee drinkers. It's the number of times it can occur, right? I'm randomly selecting one person out of the total number of outcomes, the total number of people, which is 36 students in the class. And that's how I'm going to calculate a probability. I can reduce this. I'm never going to ask you to reduce it, but you can reduce it. You can write it as a decimal. A lot of times on the team activities, you'll see I convert it from the fraction into the decimal, and then you can always write it as a percentage. So I won't always write it all the different ways. Like I mentioned, this is the way in my decimal form how I'm going to write it in the future chapters, but for right now, it doesn't matter which way. Okay. I'm going to take this example and we're going to take it a step further. So out of our 36 students in our class, we have 12 coffee drinkers, 24 non-coffee drinkers, and I also looked at what year level each student is in the class. So I made what we call a two-way table, and I already made this ahead of time because it just takes too long to fill it out. So we have our two-way table here. A two-way table just represents two variables. What are the two variables? The two variables are the first one, coffee drinker or not, right here. That's my first variable. The second variable is the year level student is. So first year student, second year, third year, fourth year, fifth year student, okay? And the two-way table has values that all go for each one. So here you can see I have 4 coffee drinkers that are first year students, right? It's in that square. Or maybe I could say I have a total of 12 first year students in the class, you see? Or I might say I have a total of 24 non-coffee drinkers out of the class. So I'm going to show you how to use this two-way table. We can use this two-way table to calculate probabilities, and it's really simple. I'm going to show you this. I'm also going to show you formulas. I want you to know you never have to use the formulas. You can calculate probabilities whichever way you want. If you prefer the formulas, then go for it. If you prefer the table, you will always be provided a table. Okay, so I want you to know that. We always have that option here in this class. Okay. I'm just gonna put, I'm gonna have to turn my light off because it reflects and you can't see my thing here. So I'm gonna color my table. I'm gonna fill it in and like shade it in all the time. The different problems. Sorry, there still is a little reflecting. That's from the sun shining, which I don't want to apologize for the sun shining. It's beautiful. All right, so we're going to look at the same problem. We're just going to go further with this problem. I'm going to look at 2 problems first that are very similar to that one we just did, and then take it a little bit further. I want to practice, and we're going to look at using the two-way table. So first, I want to look at the probability of choosing or selecting at random a second year student. So I'm going to write this out in notation first, and then we will look at the table. So the notation here, I'm just going to say the probability of a second year, like that. Or you could write second year, like you could put year in here, right? If you would prefer, that's fine. You could just write second, we would get the picture. Okay, so we have this. And what we're going to do is we're going to take our two-way table and we're going to shade everything that involves the event. So the event here is second year. So I'm going to shade my table in here where it says second year. So I'm going to just shade this in here. Sorry, I know you guys can't really see it for a second. So I'm going to shade this in like that. Okay. And what we do is we're going to add everything in the squares that are shaded, and that is my numerator. So I know I have my table totals. We don't always with a two-way table. It's just here I do have them. So obviously it's easy to see it's 9, but what I want you to understand is that it's 3 plus 6, which is 9 in my numerator, out of my table total of 36. And today we are always going to be using the table total for what we're looking at. We may not always use it, but for today we are. Okay. So of course, 9 out of 36 we can reduce. Again, we don't have to reduce. I'm just going to show you. We can write it different ways, however you feel comfortable. Okay. Some people feel that pressure to reduce because it's been just told to them over and over again, you need to reduce from like algebra and calculus, and that's okay. All right, so let's move on to the next one. I'm going to do one very similar to that. And because I want to get familiar with just calculating them using the table. And it's nice practice to write the notation. So let's take a look at the probability of choosing a coffee drinker. Now, I know we just did this, so we already know the answer. But what I want to show you is that how to do it using the table. So I have the probability of choosing a coffee drinker. I'm going to shift this stuff up, maybe. There we go. Probability of choosing a coffee drinker. So my notation is probability of coffee. Now, it doesn't matter what year level, I'm just interested in someone being a coffee drinker. So in this case, I'm going to take this entire row of coffee drinkers. So rows go horizontal and columns are vertical when I refer to rows and columns. So I'm going to color in or shade in the entire row of coffee because that's what I'm interested in. And again, just like the previous one, I'm going to add these up and I'm going to get my numerator from just adding up the shaded blocks. So 7, 8, 11, 12, right? And I know it's 12 because I happen to have my table totals here, which we don't always have. So again, it's 12 and out of a total of 36 students, which of course we can reduce. We already did that on the previous page. I'm not going to do it again. We can just leave it at that. Now let's go ahead and take it a step further. So let's add a little bit more to this. So let's take a look at the probability of a second year student or coffee drinker. So I'm interested in the second year student or the coffee drinker. I've added in this word or. And if you've noticed, I've introduced 2 events, not just 1 event at this point. So before we just were doing second year or just coffee drinker separately. Now we're going to have both of them together. So what this means is I'm going to write this as probability of second year. And I'm just going to write the word or coffee. And I think that gets my point across. I'm interested in the probability that if I choose, randomly select one student out of the class, that they are either a second year student or a coffee drinker, or they could be a combination of both, but they're at least one of those, okay? That's what we're looking at. So again, we're gonna go back to our two-way table. We're going to highlight the events that we're interested in. The events we're interested in second year, coffee drinker. So I'm going to take my second year and I'm going to shade in my table, and then I'm going to take my coffee drinkers. I'm going to shade in my table here. And so what the two-way table does is it allows us to add up all the boxes that are shaded only once for each of them. And this allows me to get away with calculating probabilities without using formulas. So here, I can add these all up. We know this is 12, first of all, because we just did it in the problem before, but we also have the total here. So I'm adding all these up. I get 12 plus 6 gives me 18 in my numerator. And again, even though I'm putting 2 events together, I'm still looking out at my overall class of 36 students. So it's 18 out of 36. I can write this as 1/2, 50%, right? Different ways. So here we're taking an or, which means that someone can be coffee drinker or second year, or you can see right here with these 3 students, it's both. Now, if you were to do this by hand with formulas, what happens is this, this 3 might get counted twice. So we have a special formula for that. And I'm going to show you that in a little bit. So the table allows me to count all of the shaded boxes once. And I don't have to worry about double counting those 3 students that overlap, that are second year and coffee drinkers. That's when this table comes in really handy, and it's really nice because I feel like there's less room for mistakes. All right, let's take a look at another one, very similar to that one, but a little different. So this last one we're going to look at, this is the probability of choosing a 4th year student and coffee drinker. So now I want to know, what is this probability that I have both? Look at this, I have an and. So when I have an and in my statement, this means I'm interested in the overlap of the 2. That I want to know, what is the probability that I choose one student and they're both? They're a coffee drinker that's in their 4th year of study at RIT. Okay, that's what I'm looking at. So it's the probability of 4th year and, I'm gonna do it caps, although my N is lowercase, that's okay, and coffee drinker. Like that. Okay. Again, I'm going to use my table. I'm not going to worry about a formula just yet. I will show you some of these formulas here shortly. I'm just going to use my table. Remember, what I'm going to do is I'm going to shade in the events. It's just in this case, I don't have 2 separate events because I'm looking at an and, means I want them to be where the intersection is. I want it to be the overlap of 4th and coffee drinkers. So what I'm looking at is my 4th year column and those students that are coffee drinkers. So I'm just looking at this one box right here. And again, it's still just out of my table total. So in here, I'm looking at 3 out of 36 students that are both fourth year and coffee drinkers. So I have 3 out of 36 that I could possibly choose. That's the probability choosing someone that's a fourth year coffee drinker student. So that's using the two-way table. I think it is super helpful. I love it because it's like a little visual. It's you don't have to think about rules of formulas and all that stuff. But I am going to show you the formulas because some people really like to see formulas. They really like to use formulas, and it's completely fine with me. I like you guys to use whatever works for you. Everyone's a little different, and everyone should use what they like. Although on the team assignment, I will have you use both. I will have you practice both because I'd like you to see them both. So let's look at some formulas here. So we're going to start with what we looked at here with the third one is an or. Okay, we're going to start with that today. So we're looking at the probability of A or B. When we're looking at an or, this or right here, this is my addition rule. So when you see an or, I want you to think of addition because you're taking the two separate groups and you're putting them together and you're going to kind of look for just one out of either one of those groups, okay? So it's bigger. So my notation here, I have additional notation to show you. So I have probability of A or B, like I just did in the previous example. Or we can write it with a different notation, which is called the union symbol. So it's the probability of A in union with B. And this union just means or. That's all it means, that union symbol. I like you to be able to use both, but I am fine with you just writing this. On the team assignment, you're going to notice I will ask you to use the union symbol. Okay? So we have probability of A or B. You still say it like that. You don't have to say probability of A union B. You can, but you could just say, if I was to read this, I would say it's probability of A or B. That's how I would read it. And the equation for this is the probability of A plus the probability of B. It's the union, it's the addition of the two. Now what I want you to know is this is a special case. So I have two formulas I'm going to give you for this. And the first one is the special case. The special case requires A and B to be mutually exclusive. And what that means is there's no overlap. So mutually exclusive events just means there's no overlap, meaning if I was looking at a student and I wanted to talk about a student that's a first year and a student that's a second year, there's no way for those two to intersect or overlap, right? Because you can't be a first year student and a second year student all at the same time. It can't happen. You're either a first year student or you're a second year student or maybe something else, but you can't be the two together at the same time. That's what I'm talking about. They're mutually exclusive. There's no overlap. Okay. That is for my special case. Now I want to give you what we call the general rule. And again, I'm going to write the same notation here. Let me just write an arrow so we know something new. So again, it's A or B, or I can write with my union. It's the same thing. It's just now this is my general rule. And it's still addition. It's just I'm adding something else to it or subtracting. And what I'm subtracting is the probability of A and B occurring. So let me talk about this. this is my general rule. A and B are not mutually exclusive. Oops, I did not mean that. Exclusive. There we go. Meaning that they do have overlap. Okay, I'll write that down. And what we have going on here at the end of this formula, this is where we need to subtract out the double counted. For that overlap. So I'm going to show you the two-way table again. I'm sorry, you couldn't see that. I want to give you a visual. I think the table helps us with that visual. So the general rule says A and B are not mutually exclusive, that they do have overlap, okay? And what happens is when we add just the two events individually, we end up double counting that overlap and we need to subtract one of them out. So let me just show you real quick. Here. So right here, when we're looking at this, and we were in one of the problems, we were studying second year student and coffee drinker, right? Or I want to say. So I want to know the probability of choosing second year or coffee drinker. So if we were to do it individually, we would say, okay, the probability of A would be a coffee drinker would be 12 out of 36 plus the probability of a second year, which would be 9 out of 36. But we already know it's 18 out of 36, not 21 out of 36, right? It's not the 12 plus the 9. And the reason for that is this 3 got counted twice, right? The 3 got counted in with the coffee drinkers, and then those same 3 individuals got counted again for my second year. We only want to count them once, not twice, so that's why we subtract that 3 out, and we would get the 18 out of 36 to get the get rid of that double counted 3, and we would get the correct probability. So that's just the visual to go along with that for that formula. Okay. Now I do want to mention you can always use the general rule. If they were mutually exclusive and you use the general rule, this would just be 0. So it would just be A plus B minus 0. So it would still be the same as your special case. You can't use the special case all of the time. The special case has to have mutually exclusive or no overlap. But you can use the general rule all of the time. It's just you'll have 0 here. Okay? That is my addition rule. That is for an OR problem. Now let's take a look at an AND. So the probability of A and B. So this is my multiplication rule. And again, I'm going to show you some notation. So like before I showed you, we could say the probability of A and just write it out. And B. This is the same as the notation with probability of A intersection with B. Intersection looks like a lowercase n. It looks like my union symbol, like a U, just flipped upside down, okay? So this means and. This means the and. And for my special case here, it's just multiplication. Probability of A times the probability of B. So this is my special case. The special case says that A and B, so event A and event B, are independent. So I can only use that special case if my 2 events are independent. Now, let me tell you what that means. So 2 events are independent if the occurrence of one event does not affect the probability. Sorry, you guys cannot see that. Of the second event. So that's what independence means. That one event occurring does not affect the second event. And that means they'd be independent. So if it does affect, then I don't have independence. So let's just talk about, like, verbally go over an example of this. So say I'm going to ask one of you guys to help me with a problem, right? I'm going to share my screen, ask you to help me. I'm going to just choose someone at random, right? So I'm going to choose one person out of the class of 36. And then maybe I have another problem later on in the same lecture, and I want to choose someone else, but I don't want to choose that same person again. So I'm going to take that person and kind of set them aside. They're no longer in the pool of people I'm going to choose from. Now I only have 35 people to choose from instead of 36. So that first event A occurring has changed the probability of event B occurring, because now I only have in my denominator 35 instead of 36. Okay, that's what it means. So if I just looked at B by itself, then I would have whatever my numerator is out of 36, but I've taken one away because I've already selected someone. So that's what I mean when I say independent. We're going to look at this a little bit more on the second team assignment this week, and we're going to do an example and a problem with the independence. I think it will kind of come together a little bit more. But this is a perfect example of where the two-way tables are so much easier, right? Because we did an and on the two-way tables, right? It's the overlap. We didn't have to take numbers, we didn't have to multiply them, we didn't have to think about if they're independent. We just looked at the table and we took the overlap, and that's the value, right? That was the probability. So that's where I say these two-way tables are really simple and clean and just quick for us, okay? So of course, though, I have no judgment on anyone. If they would rather stick with the formulas, I'm just telling you, you don't have to stick with the formulas, okay? So